All right, welcome everybody. Lesson number 30, differentiability within some sort of system of equation. So systems of equations, this is an Algebra 1 review, so let's just review this concept. And this topic, this lesson today will be easy peasy, really not too bad. But okay, so let's see. Find the solution for the systems of equations. So maybe it's been a minute since you've seen this, but if you have a system of equation, how do you solve for x and for y, right? Pause the video and try and solve it yourself if you remember, and if you feel like you forgot, let's see. So the first move is, notice that you want to have a positive and negative of the same value, right? So here this is a positive 10. You want to make this into some sort of negative 10. So how would you do that? Here, let's multiply the top and the bottom by multiply the bottom by just negative 5. Hold on. System of equation, and the idea is we want to, what do we want to do? We want to get, you see how we have a positive 10x here? We want to get a negative 10x here. So what we're going to do is multiply both sides by negative 5. So what happens here is this becomes 10x. So the top remains the same, 10x minus 9y equals negative 32. But then the bottom becomes negative 10x plus 50y equals negative 50. And then notice when you add the equations, when you add positive 10x and negative 10x, these two cancel. And then when you add negative 9 plus 50y, you get 41y equals negative 82. Now notice you have an equation and you just have one variable by itself. So here you could just divide both sides by 41 and you get y equals negative 2. Now that you have y equals negative 2, you could plug it into either the top or bottom equation. Now you have, let's say, 10x minus 9y equals negative 32, 10x minus 9 times negative 2, because y is negative 2, equals negative 32. So you have 10x plus 18 equals negative 32, minus 18, 10x equals negative 50, x equals negative 5. Okay, divide both sides by 10. Cool. Try this one as well, and if you're doing this problem, trust yourself if you get fractions. Okay. Let's take a look here. Here you have negative 6a minus 8b equals 11, and 3a plus 8b equals negative 5. Notice you have a plus and minus of the same number, 8, so we could just, the b's will cancel once you add them. So here, these cancel. So negative 6 plus 3 is negative 3a equals 11 minus 5 is 6. So then a is equal to negative 2. Okay? Now that we have a is negative 2, we could plug into any equation. Let's put it into the bottom equation. So if you have 3a plus 8b equals negative 5, a is negative 2, so 3 times negative 2 plus 8b equals negative 5, negative 6 plus 8b equals negative 5, plus 6 plus 6, 8b equals 1, because you're doing plus 6 here, right? And negative 5 plus 6 is 1, divide both sides by 8, and you get b is equal to 1 over 8. Okay, so it's okay to get a fraction. Okay, great. Now, how do we actually do some calculus? Because this is Algebra 1. Here, let's take a look at this question here. It says, determine the values of a and b for which would result in the function f of x being differentiable at x equals 1. So here you have a piecewise function, and you know that, let's say if this is the number line, this is 0 and this is 1, right? You know to the left, for the left of 1, which function would exist? It would be the 3ax minus 1, because here when x is less than 1, when x is less than or equal to 1, the graph will be, the function will be using, the piecewise function will be using this, and to the right of 1 you have 2bx squared minus 2x plus 9. So the idea is what is the value of x, what are the values of a and b that would make the function differentiable at x equals 1? So one important thing from last class we have to be conscious about is if the function is differentiable, then it must be, or it is, continuous. So the idea for this question is if you have continuity, then the limit from the left must equal the limit from the right. So because we know this function is gonna, or we're trying to make the function differentiable at 1, it has to be continuous at 1 as well. So the idea is, let's take the limit of f of x as x approaches 1 from the left has to equal the limit of f of x as x approaches 1 from the right. Okay? But what is the function from the left? It is 3ax minus 1 equals 2bx squared minus 2x plus 9. And now here, x is equal to 1. So here, let's just write continuous, right? So we're just going through that notion of continuity, that the limit from the left has to equal the limit from the right. So now you know x is 1, so let's plug in 1. So now you have 3a times 1 minus 1 equals 2b times 1 squared minus 2 times 1 plus 9. So now you have 3a minus 1 is equal to 2b minus 2 plus 9. So that's 3a minus 1 equals 2b plus 7. Okay? And once you get to this point, let's try this. Sorry. Get a and b on one side. Okay? So get a and b on one side. So here, how would it look like? Let's minus 2b. So you have 3a minus 2b. And let's plus 1 it to the other side. So this equals 8. Okay? So you see, take your time and pause the video if I went too fast. But okay, so that's what we have for continuity. What's the next thing that has to be true is we have to have differentiability. And what was the idea of the function being differentiable? That the limit from the left, the limit from the left has to equal the limit from the right. Okay? And then what did we do in the last kind of lesson? We took the derivative of each function from the top and the bottom. So here, because we have differentiability, or we want it to be differentiable, I want differentiable. So we know that the limit as x approaches 1 from the left of f prime of x has to equal the limit as x approaches 1 from the right of f prime of x. So the idea for here is, let's take the derivative of the top and the bottom. So what is the derivative with respect to x for the top? It'll just be 3a, that's it, 3a. Okay, because if you take the derivative of x, it's just 1, right? And minus 1, this was 0. What's the derivative with respect to x over here? This would be 4bx minus 2, and that's it. But notice it's at x equals 1. So now we have 3a is equal to 4b times 1 minus 2. So 3a equals 4b minus 2. And the idea is the same going to be here. Let's get a and b on one side. So notice that if I do minus 4b, so 3a minus 4b equals minus 2. And okay, we can't continue any further. So notice that what were we able to kind of generate with this whole entire thing? Notice that you have one function here. I'm sorry, not one function. You have one equation here, which is what? 3a minus 2b equals 8. And you have another one of 3a minus 4b equals negative 2. So what do we have over here? This is the same thing that we did from the beginning. It's just a system of equation. Because that's the whole idea. The question is asking us, what are the values of A and B? And what we were able to do, oops, sorry. Oh yeah, over here. The question was saying, what are the values of A and B? And notice, we used the idea of continuity to get one equation with A and B. Then we used the idea of differentiability to get another equation of A and B. So now we get to use the two equations, and we could set up a system of equation to find the A and B such that the functions will be differentiable. Okay? So now here, this is just a system of equation. How would you solve for A and B once you get to this point? What would you do? Pause the video and try and do it yourself, right? So here, this would be, let's say, minus 1. So then now I have negative 3a plus 2b equals negative 8. 3a minus 4b equals negative 2. Let's add these two equations. So this cancels. Now we have negative 2b equals negative 10. b equals 5. And now that b equals 5, what happens over here if I just plug in b in here? So now I have, let's try putting it into the bottom one. So 3a minus 4b equals negative 2. 3a minus 4 times 5 equals negative 2. 3, let's zoom in a little bit. Let's see. So 3a minus 20 equals negative 2. 3a equals negative 20, positive 20 on both sides, so then that equals 18. Divide 3, a equals 6. Okay? Now tomorrow, so we know what? We know that a is 6 and b is 5. But visually, what does this mean? Okay? And tomorrow we're going to use Desmos to actually figure out what on earth this means when you plug in the 5 and 6 for the a and b. What does it mean for the function to be continuous and differentiable at the point? Okie dokie. What I want you to do is try and do the rest of the problems. So try and do question 4, question 5 on your own, and then also work on the delta math for tonight. Okay? I'll see you in class tomorrow. Proud of you.